In this video, we will use sum or difference identities to find the exact value of expressions such as these. The sum or difference identities are right here. You need to go ahead and memorize these. So if you have not done so, pause the video, memorize everything on this screen. Oh, and don't forget about tangent. Pause the video again, memorize this situation. Also, I'm assuming that you have memorized this screen. So if you haven't, pause the screen and memorize this stuff. Alright, hard part's over. To evaluate this, I need to take this non-special angle and break it up into two special angles that involve either pi over 6 or pi over 3 or pi over 4. One method that I use to figure out how to split it up properly is subtraction and a little bit of trial and error. If I have pi over 12 and I subtract pi over 4, all right, which is a common special angle, sometimes this will reveal a useful fact. So if I wanted to subtract these, I would have to multiply by 3 in order to have like denominators. Now I have 1 pi over 12 minus 3 pi over 12. That's going to be negative 2 pi over 12, which reduces to negative pi over 6. That means pi over 12 minus pi over 4 is equal to negative pi over 6. Adding pi over 4 to both sides, thus moving pi over 4 to the other side of the equation, gives me the following fact. Pi over 12 equals pi over 4 minus pi over 6. So this is the fact that I can use to rewrite the original problem into a difference. So this will be the same thing as sine of pi over 4 minus pi over 6. Alright, so we went to having something that was not a special angle, and now we have the difference of two special angles. That's the key. According to the formula, this should be equivalent to sine cosine minus cosine sine. So I can rewrite this as sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. We have memorized that the sine of pi over 4 is radical 2 over 2. Alright, I'm just pulling values off my chart here. Alright, sine of pi over 4, for example, is 1 over radical 2, aka radical 2 over 2. And similarly, we know that the cosine of pi over 6 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Sine of pi over 6 is 1/2. These are all memorized facts right off the chart. Multiplying these together, I have radical 6 over 4 minus radical 2 over 4. Like denominators, so I can put these together. Alright, I will have my numerators radical 6 minus radical 2 over my like denominator of 4. So that is the answer to problem number 1. Let's do something similar with problem number 2. Again, I need to figure out how to split this up. So let's try. If I have 19 pi over 12, and let's see what happens if I subtract pi over 4. Alright, will I get a special angle is the question. So again, I would have to multiply by 3 to make this work. So what I have here is 19 pi over 12 minus 3 pi over 12. That's going to equal 16. Wow, I thought that was green. Hold on. It's going to bug me. That's going to equal 16 pi over 12. This reduces down to 4 pi over 3. Alright, both of these are divisible by 4. So this is a special angle, so we are good. So that means we have 19 pi over 12 minus pi over 4 is equal to 4 pi over 3. Adding pi over 4 to both sides, thus moving the pi over 4 to the other side, will give me 19 pi over 12 equals pi over 4 plus 4 pi over 3. So this is the fact that I will use for the rewrite. Okay, so this will be the same thing as having the cosine of pi over 4 plus 4 pi over 3. Now, according to the formula, if I have the cosine of something plus something, it will equal cosine cosine minus sine sine. So that's what I'm going to do. So I will have cosine pi over 4 cosine 4 pi over 3 minus, notice the sign change, sine pi over 4 sine 4 pi over 3. Cosine pi over 4. That is right off the chart, radical 2 over 2. Now what about cosine 4 pi over 3? Well, forget the 4 for a second. Look at the reference angle, pi over 3. What is the cosine of pi over 3? We have memorized that that is 1/2. Alright, cosine of pi over 3 is 1/2. So what about cosine of 4 pi over 3? That is either going to be positive 1/2 or negative 1/2, depending on the quadrant. Let's use a diagram to help nail it down. We are talking about multiples of pi over 3, so here is a diagram that matches that scenario. These are multiples of pi over 3. 4 pi over 3 would be right here. Okay, that is in the third quadrant. So is cosine positive or negative over here? It is negative. Alright, x value, cosine is an x value, and on the left side it's going to be negative. So that's why I'm going to go ahead and go with negative 1/2 here. Great. Sine pi over 4 again is radical 2 over 2. What about sine of 4 pi over 3? Well, forget the 4 for a second. What's the sine of pi over 3? The sine of pi over 3 is radical 3 over 2. Remember, sine of pi over 3 is radical 3 over 2. That means the sine of 4 pi over 3 will either be positive radical 3 over 2 or negative radical 3 over 2, depending on the quadrant. So here's 4 pi over 3 again. Sine will be negative in this quadrant because sine is a y value and this is below the x-axis, so it should be negative. So great. Multiplying this together, we will have negative radical 2 over 4. And here, this is going to be negative, but then I'm subtracting a negative, so it's going to wind up being addition. So I'm going to wind up having plus radical 6 over 4. Alright, minus a negative is positive. We can go ahead and put these together, so this will be negative radical 2 plus radical 6 over the like denominator of 4. So this will be the final answer for number 2. Okay, maybe I should have shown this step a little bit better. Let me just make this clear. So I have minus because of that. But a positive times a negative is a negative, so I could think of this as negative radical 6 over 4. And minus a negative is addition, so there you go. Alright, great. That was number 2. Let's keep going. Alright, for number 3, half the work has been done for us. The formula has already been used, and we already have special angles. So we can just dive in and evaluate. Cosine of pi over 3, we've memorized that that is 1/2. What about cosine of 2 pi over 3? Well, that is either going to be 1/2 or negative 1/2, looking at the reference angle of pi over 3. Where is 2 pi over 3 anyway? So here is a quick diagram. 2 pi over 3 is right here, so cosine is negative in the second quadrant. It's an x value. This is the left side. It should be negative. So I'm going to say negative 1/2. Alright, now here comes the minus. That's part of the problem. Okay, sine of pi over 3 is radical 3 over 2. We've memorized that. What about sine of 2 pi over 3? Well, that's either going to be radical 3 over 2 or negative radical 3 over 2. But here's 2 pi over 3, and sine is positive in this quadrant because sine is a y value, and this is above the x-axis where y values are positive. So I'll just leave it like this. Multiplying gives me negative 1 over 4 minus, hey look, radical 3 times radical 3 is 3. So this will just be 3 over 4. Great. So this is going to be negative 1 minus 3. So that's going to be negative 4 over 4, which is negative 1. Boom. There you go. That's the answer number 3. Okay, what else you got? Alright, for number 4 and 5, we are given some facts, and we are to evaluate these expressions. Sine of a minus b, cosine of a plus b, sine 2a, cosine 2a, and tangent of 2a. No calculator. We need to draw some triangles over here. So look, let's start with angle A. Angle A is between pi and 3 pi over 2. That is the third quadrant. So let's draw ourselves a little diagram of the third quadrant. So here you go. Third quadrant. Okay, interesting. So this is angle A that we're sort of drawing here. Alright, so everybody knows this is angle A that is happening. You know what, that's going to be kind of in the way. Hold on. I'll put it over here. Alright, great. This is angle A. Now, what do I know? Cosine is x over r. Since the radius has to be positive, this negative sign must belong to the 8. So I'm going to bump it up like that. That means that negative 8 goes here, because that's the x value. The 17 goes here, because that is the radius. What I need to find now is the y value. Take care, because this y value will be negative. So when it's time to choose, choose negative for the y value, because it's down. So what we have Pythagorean theorem wise is x squared plus y squared is equal to radius squared. So that's going to be 64 plus y squared is equal to 289. Let me just double check that. Yeah, so now subtracting 64 from both sides, that gives me 225, so I have y squared is equal to 225. if I take the square root, I'm going to get plus or minus 15. But again, I know it has to be negative because of the way it's down. So this is going to be negative 15. Now we need a similar diagram for angle B, which is also between pi and 3 pi over 2. So that will also be in the third quadrant. So that's going to look very, very similar. Okay, so what's happening now is in this diagram we're dealing with angle B. So let me be clear about that. Alright, let's see, what fact do I know about angle B? I know the cosine, and again this is x over r, and again this negative sign must belong to the 3. So that means diagram wise, my x value is negative 3, that goes there. The 5 is the radius, so that's going to go there. I'm recognizing this Pythagorean triple. This is going to be a 3, 4, 5 triangle. But this 4, just like the 15 had to be negative, this 4 has to be negative for the same reason. This y value is down. It must be negative. Alright, so there's a diagram for angle B. So now let me just set out to find all of the things I'm supposed to find. Okay, so let's start with finding sine A minus B. Okay, so if I do sine of A minus B, according to the formula, this should be sine A cosine B minus cosine A sine B. Okay, let's set all this up. So sine A, looking at the diagram of A, sine is the y value over the radius. So that's going to be negative 15 over 17. So negative 15 over 17. Cosine of B is next. Cosine, so that's negative 3 over 5. Oh, well, we were given it right there. So negative 3 over 5 minus. Now I need cosine A. We are given that, so that's negative 8 over 17. But now I need sine B. So looking at B, sine is negative 4 over 5, y over r. Okay, that's should do it. Multiplying this stuff together, negative times negative is a positive. 3 times 15 is 45. So this is going to give me 45 over whatever 17 times 5 is, which escapes me at the moment. Oh yeah, 85. Great. So that's 45 over 85 minus. A negative times negative is a positive. 8 times 4 is 32. So that's going to be 32 over 85. So 45 minus 32 is 13. So this is going to be 13 over 85. So that is the value of sine A minus B. Okay, great. What is next on the menu? Now we are supposed to find the cosine of A plus B. Alright, let me switch colors. And now let's do the cosine of A plus B. Alright, so the formula says that this should be cosine A cosine B minus sine A sine B. Okay, cosine A, that's our negative 8 over 17. Cosine B, that's our negative 3 over 5. Minus sine A, that was negative 15 over 17. Alright, I'm borrowing things from previous problems. Sine B, remember that turned out to be negative 4 over 5. So multiplying this stuff together, this is going to give me positive 24 over 85. Okay, minus positive 60 over 85. So that is negative 36 over 85. Alright, so that is the cosine of A plus B. What is next? Now it's time to find the sine of 2A. Okay, great. So we'll find the sine of 2A. Now, according to the formula, this is going to equal 2 sine A cosine A. Alright, that is just the double angle formula. So, let's see, what do I have? So that's going to be 2 times sine of A, that was negative 15 over 17. Cosine of A was negative 8 over 17. Okay, so looking at this is like 2 over 1. This is going to be 240 over 289. So that is the sine of 2A. Alright, what am I supposed to find next? So I did sine of 2A. Time for the cosine of 2A now. Alright, so here we go. Cosine of 2A. Well, according to the formula, that is going to be cosine squared A minus sine squared A. Okay, so let's see. Cosine of A, that was negative 8 over 17. I'm going to square that. Sine A was negative 15 over 17, and so now I need to square that. So this is going to give me 64 over 289 minus, and this is going to give me 225 over 289. And that's negative 161 over 289. So that is cosine of 2A. That just leaves tangent of 2A. Now, I could use another formula, but I'm going to cheat a little. I'm going to take a shortcut. Because tangent of 2A shouldn't that be the same thing as sine 2A over cosine 2A? Alright, sine over cosine. So I don't need to use the tangent formula, which I also know, but it's since I just calculated sine and cosine, it's quicker to just do it this way. So I'm going to take sine of 2A, which is 240 over 289, and I'm going to divide that by cosine of 2A, which is negative 161 over 289. Now these denominators are going to end up canceling each other out, So that's just going to give me 240 over the negative 161. Alright, so that is much quicker than using the tangent formula. Just take a little shortcut there. Alright, and I think that is it. That's the last thing I had to find. And then number 5 is pretty much the same thing all over again. First of all, angle A is between pi over 2 and pi. So that's the second quadrant. So I need to draw myself a little diagram of the second quadrant like this. Okay, so this is a diagram for angle A. So cosine of A, and cosine is x over r. So I'm going to look at this negative sign as being on the 15. So that means the x value is negative 15, and the radius is 17. Okay, if I do the Pythagorean theorem, I can find the y value. That's going to turn out to be 8, and because this is above the x-axis, it's going up, that needs to be a positive 8. Please pay attention to that. So what I have just illustrated here is a diagram for angle A. So I'm just going to remind ourselves of that by putting an A right here. So similarly, I need a diagram for angle B. Angle B is between 0 and pi over 2. So that puts it in the first quadrant. So let's go ahead and draw a first quadrant diagram then. Okay, and we are given this fact. Sine B is 4 over 5. Sine is y over r. So the 4 goes here and the 5 goes here. This is clearly the famous 3, 4, 5 Pythagorean triple. So I know that the x value is going to be 3. And this is angle B that we are drawing a diagram of. So I'm just going to remind ourselves that this is angle B. Okay, so let's go ahead and list out the things that we're supposed to find. But we'll find them one by one. Well, it's the same as last time, so I'll just do the same thing. So first we need to find the sine of A minus B. Okay, so let's do that here. So I need to find the sine of A minus B. Now, according to the formula, this should be sine A cosine B minus cosine A sine B. Okay, so what is sine A? Well, take a look at our little diagram. Sine is y over r, so that's 8 over 17. So I have 8 over 17. Next I have cosine of b. Cosine of b, so that's 3 over 5 will be the cosine. Minus cosine of a, we are given, so that is negative 15 over 17. And the sine of b, we are given, that is 4 over 5. So we just need to simplify all this down. Alright, 8 times 3 is 24, so I'm going to have 24. 17 times 5 is 85. Now this is going to be minus a negative, so I know this is going to wind up being addition, so I'm just going to go ahead and put addition. and it will be 85. 4 times 15 is 60. Alright, so that's 84 over 85. Let's see what I'm supposed to find next. Next, I'm supposed to find cosine of a plus b. Alright, so let's go. Let's find the cosine of a plus b. Well, according to the formula, this should be cosine a cosine b minus, notice the sign change, sine a sine b. Okay, what do I have? Cosine A. That's given. That is negative 15 over 17. Cosine B. From the previous problem, I see that that was 3/5 minus sine A. Let's see, that's 8 over 17. Sine B, that's given, 4/5. Okay, so this is going to be negative 45 over 85 minus 32 over 85. So this is going to make negative 77 over 85. So that's it. That is the cosine of a plus b. Okay, what's next? Alright, looks like next we are supposed to find the sine of 2a. Okay, so let's go. Let's find the sine of 2a. Now, according to the formula, this should be 2 sine a cosine a. Alright, that's just one of the formulas that we're supposed to memorize. So here we go. So I have the 2, and I have sine a, that was 8 over 17. And then cosine A, that is negative 15 over 17. So I'm going to treat this like 2 over 1. So that's going to be negative 240 over 289. Alright, that is sine of 2a. What is next? Okay, now it's time for the cosine of 2a. Okay, great. Let's do that. Cosine of 2a. Well, according to the formula, this should be cosine squared a minus sine squared a. Alright, we just are to memorize that. So cosine a, that was negative 15 over 17. And that's to be squared. Sine a was 8 over 17. And that's to be squared. So this will be 225 over 289 minus 64 over 289. So that's going to be 161 over 289. So that is the cosine of 2a. Alright, so the last thing we are supposed to find is the tangent of 2a. And just like I did last time, I'm going to do a shortcut. I mean, there's a formula for the tangent of 2a. And the formula goes 2 tangent a over 1 minus tangent squared a. Okay, so I could do that formula if I wanted to. But it would be actually easier because I've already calculated sine and cosine. It would be very easy just to do sine 2a over cosine 2a, right? Because tangent is sine over cosine. So that's going to give me negative 240 over 289. Alright, that's the sine of 2a. Alright, now the cosine of 2a, which is right here, it's this 161 over 289. See how the denominators are the same? Those are going to cancel each other out and just leave behind the numerators. So that's why the final answer is going to be negative 240 over 161. Alright, so that is the tangent of 2a. And that's the same thing we would have gotten had we used the little formula. And I believe that is all. Alright, that was the last problem. So that's going to do it for this video, guys. I hope it was helpful, and I will see you on the next video.